Did Santa Fe in the early 90s or late 80s?
I believe it was early 90s. I can get back to you.
But early 90s, Santa Fe was funded for the study of complexity theory.
It was math. So let's back up. So why did I buy a ranch in New Mexico in 1993? So that gives you some sense. So I would have funded it in 1990. Los Alamos, which was the high energy lab up in New Mexico, was losing all its scientists.
And Los Alamos, it was where Oppenheimer and where a lot of the nuclear weapons program, the bomb.
That's where the Manhattan Project.
Manhattan Project was at Los Alamos, and you bought your property out in New Mexico to be near that?
Yes. Because the scientists were going to be, they cut the funding for high energy physics. But the people who worked in Los Alamos would still be in the Santa Fe area. They
cut that because this was the Cold War dividend, right?
I don't remember exactly why. It was because, again, people thought that physics and high energy physics really wasn't that important.
Because that was about nuclear weapons.
No, it was because they decided, which may be not right, this was the same time that Murray Gell-Mann came up with the term quark, Q-U-A-R-K. He picked it out of an old poem, the word quark. But it was it was mysterious. So they were starting to understand in the 90s that in our world of the physics world, there was things that were just unexplainable. They called it strange things. You gave it a name. You gave it some characteristics. You called it had charm, was one of the terms. It had a charm. It had a flavor. It had a color. But no one, Mr. Bannon, understood what it was. Just like the financial system.
And you wanted to investigate that?
I wanted to see if we could build tools so others smarter than me could help investigate it.
And that was the beginning of your concept of the Santa Fe Institute?
Yes.
And Santa Fe Institute was founded to do study in this type of...
Can these areas of strange things be described by some form of mathematics?
So that's what I'm trying to get at. The foundational thought, the organizing principle of Santa Fe in the high physics lab at Los Alamos, which had been the headquarters of Manhattan and the Trinity Project, right, the bomb.
Yes.
So you're talking about the elite, the high priest
of physics.
Of physics.
Yes, sir.
Which high priest of physics, some subset of that is also mathematics.
Yes, they're both similar.
Project out. One of the tools you want to do is to make sure that in this complex system, the finance system, I'm doing a lot of this for philanthropy and a lot for the good of mankind, but also to be able to understand this complex system, the most complex outside of maybe our body, of the financial world.
Yes.
Did they create tools, or were you smarter in than the mid-aughts, 15 years later, than you had been then because of work that was done at Santa Fe?
No, it was great. But in fact, most of the money, most of my philanthropy in the area of can you describe things that appear to be unexplainable by mathematics, and can you fund people who have new ideas? And unfortunately, when someone thinks they've been able to, there was a man, Stuart Kaufman, when they think okay, I figured out how to be able to predict the unpredictable, what appears to other people to be unpredictable. But my system, in those days it was called genetic algorithms, can predict what things will happen, and they all want to make money. So they use their systems to try to figure out, they know they have figured out the way to make money because they figured out the unexplainable. They try, they go bankrupt, and we start again. So with a cold view, what I've come to realize is that the attempt to mathematize, formularize, or what in your prior work, to understand what really is, in today's world, still unexplainable, is impossible. They're miracles.
Your first head of Santa Fe was Christopher
Langdon, I think.
Langdon from Australia.
But Murray Gell-Mann was really was the funder. He was the rock.
Yes, he was the rock. He was a Nobel Prize winner?
Yes.
Yes, and a wonderful guy. He came out and helped us with the Biosphere 2 project. He came with Chris Langdon.
Yeah.
Chris Langdon was operated, the day-to-day guy.
Chris was doing artificial life.
Right.
Murray tried to lead his own artificial life.
Yes. When Chris came to Biosphere 2 for the first big conference we had in 1994, he was one of the most impressive guys there among all the world's elite. Kew Gardens, the Lawrence Livermore Lab, the labs at Sandia, all the major universities, Lamont Doherty, all the big Earth observatories, Woods Hole. What set Langdon apart, I thought, and the reason I invited Santa Fe to be part of it, was Langdon actually made a presentation that everything, and he was making this to scientists, a lot of marine biologists, a lot of people that were just beginning, Wally Broker and people who were just beginning the study of climate change, at that time called global warming. That he made this compelling presentation that everything's really mathematics. Yes. It's all just back to math. And you have to, all these experiments you do, you're not, one of the reasons they're not considered by the high priest in physics as being real experiments is that they don't have a mathematical basis to it, and everything has a mathematical basis to it. Langdon seemed like a radical visionary. What happened to that concept?
You go back 350 years. So you have Isaac Newton, you have Leibniz. From move forward, you have people like Heisenberg and Gödel, and what every one of those mathematicians and philosophers came to understand is that there's something there's numbers can describe certain things, approximate certain things. But in fact, trying to put measurements and numbers on other things that are really unexplainable is folly. So 300 years ago, they said that unexplainable realm was God. And people who attempted, in fact, to explain the unexplainable, who said, yes, I understand the unexplainable, were charlatans, they were the occults, they were the astrologers, they were the con men.
Alchemist.
Yes. Well, no, alchemist was, in fact, they believed that there was a way to transmute one metal into another. In fact, they always wanted to see if they can create gold. There's no reason, if you think about it, they recognize that one metal is different than another metal because it has some additional pieces to it. It has additional neutrons or protons or electrons. So because they thought it was a machine, they believed it was a machine, if I can take 5 protons and add 5, that gives me 10, I should be able to get gold. Move everything around inside these systems, the molecules transmute one molecule into another, and if this molecule I've transmuted it into is gold, I'm a rich man. It's back to money. But there's something strange happens. Isaac Newton says, this is really weird. If I want to push a ball on the table, I have to touch it. Maybe I have to blow on it. But I actually have to push one side of the ball or the book to move that side. I'm pushing here, and obviously this thing is what appears to us humans to be solid, so it moves as one thing. But the only way to get something to move was to touch it or put a force against it. Okay, seems to make sense. Everybody has that experience. I want to lift a glass, I lift it. If I want to push a ball, I push it. If I want to pull a ball, I pull it. But he recognized when the ball fell off the table, it went in a different direction. How's that possible? Nobody pushed the ball down. And he said, this is crazy. Why did the ball go down? I didn't push it. I just let it go. So someone's pushing the ball. Because I know that I am confident that the only thing that gets something to move is with a force that pushes. So there's a force that's pushing the ball down. In fact, he called it gravity. He measured how fast it was pulled, but never was able to explain why it happened. How is it? What is gravity? It's this. Everybody says, well, why did the ball fall to the ground? Because gravity took it. But what's gravity? That's, as Feynman would say, that's the name of the thing we have no idea what it is. This goes to Santa Fe. They were trying to explain the unexplainable. Can we measure? can we figure out a way to predict the stock markets using these types of chaos complexity?
Before we get there, let's walk back through it. Let's go back to Newton.
Sure.
Pre-Newton and then Newton. What did Newton solve that for millennia up to Newton had not been solved? And then I want to go forward all the way to Santa Fe, what they were trying to solve. Let's start with just 2 or 3 of the basic guys, but let's go with Newton. What pre-Newton, it was what? And then why is Newton such a
genius?
In such a in the, I think mathematically they told me one time, I've seen there's been 115 billion people roughly that have lived on the earth. And of that 115 billion, Newton.
Are you sure that's a number? That sounds a lot very high. We only have 7 now.
I think in the history of the earth, I think it's, I'll pull up the stat for you, but I think it's 115 billion people. They figure
that probably is inflation. That's why
have lived on Earth. But he's one of the handful of the most important. What did he solve for? Why is he so important for how we live today? And then we want to go through Leibniz and the other 2 or 3 other major ones to get us to Santa Fe.
Well, it's a long journey.
This is the heart of what we're trying to do.
Let me take a bit of a detour just a second. What if you went to high school and the last year in your high school you took calculus? So Isaac Newton sort of invents calculus. Well, that sounds invents, mathematicians.
To torture seniors in high school before they graduate.
Yes, but obviously no. Yes, the answer is yes. Certain people could never do calculus.
Why is that? Why is calculus so? Why is that the dividing line between, to me, people who can handle that and can go on to do certain things, and people just hit the wall, even if they know math? It seems to me that there's that calculus is the thing that changes. It bridges. That's because it's about the theory of change and the theory of how things change.
It's a great question. But in fact, what calculus does is it's somewhat philosophical. That's why mathematics Newton wasn't a mathematician, he was called a geometer. That's what they used to call themselves. They understood geometry and numbers. But there's an old conundrum where it says, during Pythagoras' days, Zeno's paradox it's called, where they said, well, if the wall is 2 feet away from me, and I take 1 step that's halfway to the wall, that'll be 1 foot away. And if I take another step that's half again, that'll be half a foot away, and then 1/4 of a foot. I could walk forever but never touch the wall. Doesn't sound realistic, doesn't make any sense in our real lives of the physical. But what Newton understood is many problems were like that. Many things approached the wall, or in calculus, approached the limit, but never really reached it. So he said, it's okay, you don't have to reach it. We can do lots of the mathematics as if it was so close, it was almost there. And we could do lots of mathematics almost being at the limit. And this is really important, Steve, for today. Because most of the science up until today was things that are starting to approach the limit. You were taught in high school that if you had 1 divided by 0, if you remember your high school algebra, you were told, what's the answer to that? Is there an answer to 1 divided by 0? No, if you were in high school, I'd say, stay away from it. It's the boogeyman. You could write it down as it's undefined. It's not able to be determined. There's a bunch of things. But in fact, 1 divided by 0 is a strange things happen. It's a world of the strange. And what I'll explain to you after is that when you get 1 divided by 0, you get into a world we don't know what happens. The answer is it's not explainable. We can call it things like undetermined. We can have a convention to say it's X, Y, or Z. But in real life, we don't know what happens when you are actually at the limit. So Newton thought the same concept, is that the limits were God. You got close to God, but you can never be God. He had this sort of religious interpretation.
Okay, I want to go back to Newton. Why is Newton such a big dividing line in mankind's history? What is it about Newton? What is it about what he's trying to solve? What did they not know beforehand? And what? Because we live to a degree in a Newtonian universe, although I realized later subparticle atomic physics, but at least for a while it was Newtonian. So what's the dividing line? Why is he so important? Why is he an inflection point in mankind's movement from the swamp to the stars?
It's a great question. The stars were by Kepler. What Newton starts to allow us to do is to make accurate predictions. Remember that we've talked about that with money, about the things in our physical world, how cars, he didn't have cars then, how horse carriages moved, how bowling balls moved, how pool cues and pool, pool table balls.
Had people tried to solve that before Newton?
Many.
Tried it? Heraclitus or Plotinus, Pythagoras, had these greats that we hear about, had they tried to solve the same problem?
Not the same problem. They try to, again, what Pythagoras does, he starts to figure out this relationships in triangles. For example, everyone knows the a squared plus b squared is equal to c squared, that Pythagorean theorem, which is basically says these shapes in a triangle, each side of the triangle has a fixed relationship with the other two sides. That's strange. He knew, again, but it was all numbers. This was a system of things in the physical world, and Pythagoras says we can start putting numbers on things that help you predict how they will behave. You can add two triangles and make a square, some different shapes. They were looking at geometric forms. Newton says, well, I want to know how planets move. I want to know how things around me move. Can we find formulas? Can I find formulas that explain what I see in the physical world, how physical things interact and how they describe one another? Again, the fact that two solid masses, for some very strange, unknown reason, unknown today, attract one another, no matter what they are. People have seen the experiment. You hang something, two little metal balls from a string, and they move towards each other. In fact, they move towards each other was very specific. So when you drop the ball to the floor of this room, Newton says, in fact, the room came up a bit to meet the ball. The room moved. It's imperceptible. You can't really perceive that motion, but they attracted each other with certain ratios. So he started to be able to measure things in the physical world. And that was great advances. It also, you wanted to move very quickly. Unfortunately, most people, especially in the 20th century, 19th century, said, well, like Newton, let's measure everything. Let's measure people's behavior. Let's measure their psychology. Let's measure their health. You go to we can have my blood test. Let's measure everything. We measure Wall Street.
Their voting habits.
Measure, measure, measure. Can we put a number on how much I care for my wife? Can I put a number on how I feel? And we tried, unfortunately, we try to mathematize the finer things in life, and then recognize that there's things that, unfortunately, just fall outside. Schrodinger wrote a very famous book about what is life. He was trying to figure out a way, can he describe the difference formulaically between things that are alive and things that are dead? The answer is no. The things that are alive in my world are miracles, not magic. Magic has a bad connotation, trying to hide things.
You don't believe in the spirit or the soul? That's what animates people, is your spirit or your soul. That's
no.
Have you ever seen someone die? When they die, their spirit leaves.
Their soul leaves, no question. So
there's no question to you about
no
that.
question.
There's no question to you that there is some animating life force within us that leaves when you're dead.
Yes, in fact, I refer to the soul. This obviously a certain the questions in the past, even
because
during
people would normally think you were soulless. So
thank you.
But have you talk about you actually believe in it and have done some thinking about it is pretty shocking in its own right, isn't it?
Well, again, mathematics, Leibniz and Leibniz thought...
So Newton was at Cambridge, and he was the head of the math department, right? He's a professor, essentially.
Yes.
But Leibniz, was Leibniz a German professor?
Yes. But what Leibniz said is, the soul is so strange, because God took chemicals, which is simply the material, like tables, and he somehow made this material able to have a thought. How strange is that? Not only does it have a soul, but some way it was put together that this material substance is able to think. So when you say to me, it's obvious to everyone that there's such a thing as a soul. Now, if you're part of the Charlatanville, you'll try to explain it to people. The soul I describe as the dark matter of the brain. Why is it dark matter? Because in high energy physics nowadays you hear terms of dark matter, dark energy. Again, terminology, it's a complicated term. Why is it dark matter? Because we can't see it, that's all. What do you mean you can't see it? Well, somehow we see something moving towards this area of darkness. Something, I can see this thing. This appears to me to be empty. It's just black. But I see it being drawn this way. So I say, well, I know if this were matter, that would follow that equation. If this was solid, it would explain the way this particle moves. But I can't see anything here. So I'll just call it dark matter. And I'll say, I don't know what it is, but it behaves as if there was something there. The soul is obvious to everyone that there's something different between things that are alive and things that are not alive. But we have no idea what it is. It's currently unexplainable. I believe we need an entirely different system of analysis to try to figure out.
But
Sorry.
No. With Newton, with all his chemical studies and things he worked on the spiritual side, Leibniz that just talked about the soul, Schroeder talked about what is life. If a modern scientist or someone that you funded at MIT or at Harvard or one of these things talked in those types of terms, they would be considered to be a wingnut today, wouldn't they? They would not be on the path for tenure, right?
Unless they were in the philosophy department.
This is exactly my point. We're talking about three of the greatest mathematicians in mankind's history that have really changed mankind. Talking like this, what happened? How do we get to a situation where they could not be in the high physics, they could not be in the mathematics department or working in high energy physics?
Good, it's an easy answer. Newton was a combination of mathematician or geometer then and philosopher. And as time went on, those disciplines seemed to move apart. We had philosophy. Some of the philosophers can't do math, and some of the mathematicians. And again, mathematicians often break into two categories. People that solve problems. Those are more like geometers in the old days, just problem solvers. And then there's thinkers, theoreticians. They're more like the old movement towards philosophy. But neither one of those two groups have been able to figure out why something is alive as opposed to something that's not alive. No one's been able to describe what the soul is, but we all know it exists. And I think what we need is science is a bad word. I think science only describes the things we already know about the physical world. In fact, there's an argument that the physical world that we see has been created out of our systems of mathematics. Mathematics, everyone knows mathematics describes the physical world much greater than it should, unless my view, the physical world really comes out of conscious beings that have mathematics. So they create it. This table appears to you and I to be solid. To a bat, because we have light that's bouncing off the table into our eyes, it appears solid. If instead of eyes that responded to wavelengths of visual light, our eyes responded to radio waves, the radio frequencies, it's not different, it's the same type of frequency as light, but different speeds, the table's invisible. We know that our phone works in this room. So the waves are coming through the windows, the waves are coming through the walls. So the walls are invisible to that type of radiation, that type of energy. The walls are, I can see them because my eyes, a physical system determines that the walls are there.
You, with Murray Geldman, you founded, or were the original donor, and had the idea of Santa Fe Institute. In 10 or 15 years later, that effort to study the complexity of systems mathematically,
yes,
was essentially
a total failure. Yes.
A total failure.
Total failure.
Why is that?
It's the failure of science because, in fact, if to some extent science doesn't describe romance. I don't know why I'm attracted to somebody. I don't know. People are attracted to each other, and everyone has the same feeling. They've seen someone walk in the room, and they say, "Oh, that person gives me a creepy feeling." Science has tried to describe. Science doesn't describe what creepy feelings means. They just know it's a creepy feeling. I think women, as I said the last time, have an intuitive sense. What is intuitive? They have intuition, they have feelings, and they're able to deal in the realm of things that men, especially men like myself, find unexplainable. Women have intuition, men see things a bit differently. Men want to measure everything. Women are not really that interested in measuring.
In what you're saying in macro terms, you actually think science, mathematics, maybe ultimately technology, is moving to that more intuitive?
I think science and math are old-fashioned. And unfortunately, people are still taught that they have to learn algebra in school and certain things in school, as opposed to learning to have an emotional...
Is this what Larry Summers was trying to get at? Maybe he didn't say it perfectly enough, but what he was trying to get to in that system, the systems we study today, the way mathematics is either taught or understood, that women just haven't gotten up to the highest realms of engineering or physics or mathematics because of that, and you're actually implying that there's a either new branch of science, or we've hit an inflection point like in Newton that's going to go in a... Newton took mankind in a different direction because he was able to measure. Then you had subatomic, non-Newtonian physics later. Are you saying that you think there's another developing field that's coming up that may take us, I don't know how many decades to get our hands around, but that's what's evolving out of this?
Yes. Yeah. In fact, I think that mathematics, it's not the end of science. Every year someone says it's the end of, we can't discover everything. There's lots to discover with relationship to the physical world, but we know a lot already. In respect to the unexplainable world, we almost know nothing. Women, again, sense it.